All right, ladies and gentlemen, we're going to start with the determinant of some square matrices like the 2 by 2 and the 3 by 3. If you have a matrix that's a 2 by 2 and you want to find its determinant, all right, you would do A times D minus B times C. All right, if you have a 3 by 3 and you want to find its determinant, what you would need to do is copy the first 3 columns, then copy the next 2 columns, the first and second again, all right, and then you would come down and do this product, which is AEI, that's where that came from, that's a diagonal, and then do this other diagonal, BFG, plus the next diagonal, CDH, that's where that comes from. Add those 3 products together, those 3 diagonal products, and then subtract from it the sum of the first 3 going up. In other words, GEC, that's where that comes from, and then HFA, and then IDB, all right? And that's how you find the determinant of a 3 by 3 matrix. All right, let's practice these a little bit here. Example number 1 says, evaluate the determinant of the matrix. Well, we're going to do that product coming down, okay? All right, so the determinant, let's call this matrix A, okay? The determinant of matrix A would be equal to 4A times 7B, all right, minus 3B times negative 2A, all right? So this would be equal to, 4 times 7 is 28, so that's 28AB. All right, a negative times a negative is a positive, so that's going to be plus. 3 times 2 is 6, and B times A is the same thing as AB, so that you get these lined up and see that they are indeed the same. They are like terms. You can combine them into one, and that would be 34 times AB. All right. Now, there's your answer for example number 1, 34AB. All right, example number 2 says evaluate the determinant of the matrix. Well, you do product coming down. Let's call this matrix B. Let's say this is matrix B. If we want the determinant of matrix B, that would be A times D, 5 times 4, or excuse me, 5 times 1, decreased by B times C, 4 times 3. All right, 5 times 1 is 5, minus 4 times 3 is 12, and when you subtract 12 from 5, you would get negative 7. Now, since this one doesn't have any variables on it, I'm going to make sure you see how you can check that with your calculator, so let's do that. Now, I don't know what's in my calculator, all right, so what I'm going to do is I'm going to just immediately do clear the RAM so I can start from fresh, all right? And I'm going to do second matrix, and I'm going to edit, and I'm going to edit A, or let's put it in B. We'll do B. I'll edit number 2. It is a 2, which is a B. 2 by 2. All right. Row 1, column 1 entry is 5. Row 1, column 2 entry is 4. Row 2, column 1 entry is 3. Row 2, column 2 entry is 1. All right, and then I'll double check 5, 3 for the first column, 4, 1 for the second column. I'm good. All right, and now if I want to find the determinant, I go second matrix, and then the determinant is a mathematical. Oh, there's the determinant, number 1. If you see it says DET, that means determinant of, I need to tell it which matrix I want the determinant of, and that means I need to go get the name of it, which is the B, number 2, all right, and then it'll come back and it will give me that negative 7 that I put in, that I got right here. So yes, negative 7 is the correct determinant for that matrix. I'll box that in, and we'll go look at example number 3. Example number 3 is a 3 by 3 matrix, all right? And if you want to find the determinant of a 3 by 3, start by just copying down the matrix itself, okay? And we're going to do this by hand and with the calculator, by the way. All right, there's the matrix itself. I'm going to duplicate column 1, which was 2, 4, 3, and then duplicate column 2 again, negative 1, 1, negative 4. And then I'm going to come down, okay? This would be equal to, all right, I will come down and do that, 2 times 1 times negative 2, okay? So, and I'm going to do that inside. 2 times 1 times negative 2, all right? 2 times 1 times negative 2, plus I'm going to do negative 1 times 0 times this number right here, 3, all right, plus... Then I'm going to do 3 times 4 times negative 4. So negative 3 times 4 times negative 4. All right, that will give me a sum. All right, then I'm going to subtract from that sum. All right, let me move this over where you can see it. I'll zoom out a little bit. Okay, the diagonals going up starting from the bottom left. Okay, 3 times 1 times negative 3. 3 times 1 times negative 3. Plus, I would do negative 4 times 0 times 2, negative 4 times 0 times 2, plus I would do negative 2 times 4 times negative 1. Negative 2 times 4 times negative 1. All right, and then I'll add those up. All right, so now let me go in and do these products. 2 times 1 is 2, and that 2 times negative 2 gives me negative 4, plus... Negative 1 times 0 is 0, times 3 is 0. Negative 3 times 4 is negative 12, and negative 12 times 4 is 48. So that would be plus 48 minus, all right, now we're right here. 3 times 1 is 3, times negative 3 is negative 9. Plus 4 times 0 is 0, times 2 is 0. All right, plus negative 2 times 4 is negative 8, and negative 8 times negative 1 is positive 8. All right, so then I would have here 44, all right, minus negative 1. Okay, when I add those up, I get negative 1, but that's really the same thing as that, so this should be 45. All right, now let's double check it just to make sure. Okay, all right, I'm going to hit clear. Let's call this matrix A. Okay, so we'll go into second matrix. We're going to edit A, which is the number 1. All right, it is a 3 by 3. It has 3 rows and 3 columns. Row 1 is 2, negative 1, negative 3. Row 2 is 4, 1, 0. Row 3 is 3, negative 4, negative 2. Okay, all right, now let me make sure. I'm going to check these columns real quick. 2, 4, 3 is column 1. Negative 1, 1, negative 4 is column 2. Negative 3, 0, negative 1 is column 3. Okay, so I'm going to go back to the home screen. I want to find the determinant, so I'll do second matrix, go to math, determinant is 1. All right, and then I need to tell it which matrix I want the determinant of. So I'll go back into matrix and get the name of the one I'm looking for, which is matrix A. And then when I hit enter, I should get 45. And I did, and there's how you do it by hand and with your calculator. Okay, all right, let's go to the next page. The next page is how we find the inverse of a 2 by 2. All right. And we can do that by hand, all right? It's not too complicated to do it by hand. If you have a matrix A inverse, and that is not always equal to A. That should be a comma. A inverse, or the inverse of matrix A, all right, is 1 over the determinant of A times reverse A and D, and then change the signs on B and C, all right? And since the determinant of matrix A is... and by the way, we probably ought to put over here, A is equal to the matrix A, B, C, D, all right? If that's the case, then the inverse would be 1 over AD minus BC times D, negative B, negative CA. All right, provided, of course, AD minus BC is not equal to 0. Because if it were equal to 0, you'd be dividing by 0, and that would not be possible. Okay, all right, so if we want to find the inverse matrix of A, we're going to do, and I like to think of it this way right here, 1 over, I'm going to do A times D. Well, that's 3 times 5. 3 times 5 minus, I'm going to do B times C. Well, that's 8 times 2. 8 times 2. All times the matrix, we're going to switch the roles of A and D. So 5, 3, change the signs on B and C, -8 and -2. And then we're going to figure out what this determinant is. Oh, that's 15 minus 16, which is -1. So that's 1 divided by -1, which is -1 times 5, -8, -2, 3. And really, when you multiply by this scalar, -1, you just change the sign on everything in there. So A inverse will be equal to -5, 8 for row 1, and 2, -3 for row 2. All right, now let's double check and make sure we found this correctly. All right, now that's so I'm going to go second matrix, and I'm dealing with matrix A. So I'm going to maintain A in here. So I'm going to go edit number 1. It is a 2 by 2. Row 1 is 3, 8. Row 2 is 2, 5. Okay. Now, if you want the inverse of this matrix, what you need to do is go to your matrix menu and get the name of that matrix. Well, that was matrix A. And to get the inverse, just hit the matrix button without hitting the blue, and that'll give you the inverse. The negative first power is also the inverse when you're dealing with matrices. And when I hit enter, I should get -5, 8, 2, -3. And I did, and that tells me that I've done it and done it correctly. Okay, and you can see it right there is the A inverse. It should give you the exact same thing that we have right here on the paper, -5, 8, and 2, -3. Okay? All right. Now, for a 3 by 3, doing it by hand is really complicated, and I'm not going to ask you to do that, but I do want you to be able to do it with a calculator. So let's do that right here. All right, let's do second matrix. We're going to edit, and let's call this one, it doesn't matter. We'll call it A. We'll say this is matrix A. All right. If it's matrix A, we would go to edit 1 to get A. It is a 3 by 3. Row 1 is 2, 1, -2. Row 2 is 5, 3, 0. Row 3 is 4, 3, 8. Okay? All right. Now, we want to use this to find the inverse. Now, I will tell you that we could do a determinant, by the way. If you just wanted to do the determinant, I'm going to show you that real quick. You'd go math, determinant 1, and then we put it in A, and there it is. There's your determinant. It would be 2. Okay? Now, we didn't want that. We want the inverse, so we would just do second matrix. We've got that matrix in 1, which is A, and A inverse will give us this matrix right here. So A inverse would be, all right, 12, -7, 3, -20, 12, -5, 1.5, -1, and 1/2. That would be the inverse of that 3 by 3 matrix. Okay, if you have any questions, you're going to need to show up in a Google Meet or call me or email me, whatever you need to do to get your questions answered. I hope you have a good day. Thank you. Bye.